The parent exponential function is the function f of x equals b to the x power, where the base, b, is a constant number, and the exponent, x, is the independent variable, or the thing that can change. A function of the form f of x equals a times b to the x power, with a greater than 0 and b greater than 1 is an exponential growth function, which increases as x increases. When you are building an exponential growth formula, it should usually be of the form a of t equals a times 1 plus r to the power of t. And what these variables all mean, the a of t, that is going to be your final amount, or your total amount of whatever you're looking for. The lowercase a is going to indicate your initial amount, or wherever you started in your population or your amount of money or whatever. And then your r, lowercase r, is going to be the rate of increase. And finally, the t, which is in the exponent, so the t is your independent variable, which was the x before. And this is just going to be your time, the time periods that it has passed by. And this is going to be in years. Now we're going to do some examples. Clara invests $5,000 in an account that pays 6.25% interest to her each year. How much money will she have left in her account after 8 years? So we need to come up with our formula. A of t equals a times 1 plus whatever my rate is to the power of t. So now we just need to fill in what we don't know. So fill in the a, the r, and the t. So that would make it my a being my initial amount, 5,000, times 1 plus my r, which is my rate per year, which is 6.25%, or 0.0625, to the power of t, which is the number of years, 8. So to the power of 8. Now I just have to simplify this problem. So that would be 5,000 times 1.0625 to the 8th power. And that is what you type into your calculator to solve. And your final answer, a of 8, equals 8,120.85. And that's your final answer. Next example, in 1981, the Australian humpback whale population was 350 and increased at a rate of 14% each year since then. What will the whale population be in 2000? Okay, so we know it's exponential growth, so we're going to have the formula a of t equals a times 1 plus r to the power of t. Now in this case, we don't yet know what t is. So we need to first find t so we can plug everything in. We know that the initial population was in 1981, that was given to us, and now we want the population in 2000. So we can find the change in the time based on those 2 years. 2000 minus 1981 is 19. So that is your time. So now we can put in what we know. So we know that a of 19 is what we're looking for, equals my initial a, which was 350, and it increased at a rate of 14% each year, so that is my r, my rate, 1 plus 0.14, to the power of my t, which we already discovered was my 19. And then I can just simplify. A of 19 equals 350 times 1.14 to the 19th power. And then my solving, a of 19, if you type that in the calculator, then you would get roughly 4,219. And since you can't have half of a whale, just round to the nearest number, and that'll be good enough. So there would be 4,219 humpback whales. And that's your final answer. Those are your notes over exponential growth. Do some practice problems so you understand this technique, and then watch the exponential decay video, and then you'll be ready for your quiz over exponential functions.